This is your video notes for our state testing review for Unit 3, Features of Functions. So we have this graph, and what we're going to do is we're going to go over 6 different features. Actually, I think there might be 8. And then we'll show you the definitions, and then we will go over the second part of Unit 3, which was evaluating functions. So the first feature that we're going to go over is a maximum. So a maximum is the highest point on the graph. So this graph would have a maximum up here at -10, 7, right there, would be the maximum. -10, 7. When you write that as an ordered pair, it's a single location on the graph. A minimum is the lowest point on the graph. So our lowest point is right here. Minimum. And again, that's a single location on the graph. So this would be at -7, -5, it looks like. Okay, so that's just ordered pairs so far. Our next 2 vocab terms are x and y intercepts. Let's do the y-intercept because there's only one of it. So this is the y-intercept right here. Y-intercept. And this one is also a single location on the graph. It's an ordered pair, so this would be at 0, 5. Okay. Our x-intercepts are right here. We've got 2 of them. So here's one, and here's one. And we're going to say that this x-intercept is at -9, 0. And then this other one here is at -4, 0. Okay, so those are 4 features that are locations on the graph. It's a single point. So the next features are intervals. So they span a whole section of the graph. So let's do our domain first. Okay. So the domain is all the x values. So I'm gonna actually turn on the highlighter and show the domain. So it looks like our domain starts here at -11, right? This is our first x value, and it goes all the way to 9. So that's our domain. So I'm going to write here domain. It's all the x values. And it looks as if the x values end at -11, like there's nothing to the left of it. And they end, well, that kind of looks like almost 9.5. So let's just say over here at 9.5. So we're going to use square brackets for this interval. So the domain is going to be square bracket -11, that's where it starts, all the way to 9.5. So 9.5, and we'll close it with a square bracket. And then we're going to do our range. So the range is going to be all the y values that exist on the graph. So the lowest y value down here is -5, and then it goes all the way up here to, looks like it's 7 is the highest one. So the range actually has part of the minimum and maximum in it. Do you see that? It's from -5 all the way up to 7. So let's write that range. So range is all the y values that exist on the graph. And I'm going to do a square bracket because there's nothing below -5. And then all the way up to 7. Again with a square bracket. Now if one of the sides of the graph has an arrow that indicates it goes like, let's say it goes up forever. So let's say over here on the right, this had an arrow, then instead of going from -5 to +7 for a range, it would be -5 to infinity, right? Because it's going up forever. Our domain would also be affected, right? And next to an infinity symbol, you would put a parentheses. So just bear in mind that your domain and range don't always end and start at a specific number. It could go on forever, right or up, that's positive infinity, or left and down, which is negative infinity. But for us, we've got terminating ends, so we've got square brackets. Our last key features are increasing and decreasing. So there's a whole bunch of places where our graph is increasing. So I'm going to show those intervals. So it looks like it's increasing in this little piece right here, this piece right here, and this piece right here. So we've got 3 pieces of increasing, and it looks like we're decreasing in 2 pieces. So right here and right here. So the increasing portions, we use the x values to describe where it's increasing. So I'll show you how to write those intervals. So it's increasing, so I'm just going to write INC for increasing. Looks like it starts increasing at -11, nothing before that, so square bracket, all the way to -10, close parentheses, in union with, remember that union symbol, and then -7, so this is just parentheses, -7, comma, looks like at 0, where it stops increasing, and then again, union with 4 to 9.5. 4 to 9.5, and 9.5 will get a square bracket. So that's where it's increasing. Where it's decreasing is, so we'll write those decreasing intervals. So we'll write DEC for decreasing. And it looks like it's decreasing from -10 all the way to -7. Just has parentheses around it, in union with 0 to 4. Okay, and again, those are the x values where we're seeing that behavior. It's almost like the x-axis is time, and we're saying from this time to this time, the graph is decreasing, it's going down. Okay, so I'm hoping that you copy this graph onto your notes, and then also copy the definitions down below. So I'm going to encourage you to pause it right here and get it supported. And then once I move down to the vocab, pause it again and record those. Okay, and then here's the vocab. Everything that we just went through. Maximum is the highest point on the graph, minimum is the lowest. Increasing is an upward slope, decreasing is downward slope. Y-intercept is when your input is 0. We learned this in the context of emptying or filling a pool. So when the pool is full at the start, and your x-intercept is when your output is 0, and where the pool is empty during cleaning. Okay, but for us, this is not really a pool, so this is Well, the y-intercept is where your graph crosses the y-axis, and the x is where it crosses the x-axis. So maybe I'll cross those out and just say when input is 0, I'll just not worry about the relation to the pole. Okay, and then your domain is beginning to ending times. It's all the input values. These are the x values. I'm going to zoom in a little bit there. X values. And your range is empty to full. And those are the output values, the y values. Okay, so that is the first part of Unit 3, where we talked about key features of functions. Now, the second part of this unit was evaluating functions, so I'm going to go over that briefly. So let's, if you need to pause right here to record your vocab, I would recommend it. But I'm going to move on now onto the evaluating functions. So evaluating functions. So when you need to evaluate functions, it's going to look like something like this. It's going to say find f of, f of 2. And let's say it's referencing a graph. So, and I'll just look up here in the graph that we copied down for the key features. So finding f of 2 is saying when x is 2, what is y? So I would look over here where x is 2, right? This is where x is 2, and I'd go up and I'd read the y value. So it looks like it's 4. Okay. So then I'd say, okay, find f of 2, f of 2 equals 4. Okay, and it could also give you like a backwards question. So it could say if let's say oh yeah, that's right, that's how they do it. If f of x equals, I don't know, let's do -2, find x. So that's how a backwards question looks. So it gives you the y value, right? This one is here is the y value. And it says, well, what was the x value? So I'm going to go up to the graph and I'm going to read off the y value of -2 and then see what x value I have, if I have one or if I have many. So let's go to y is -2. So it looks like it's right here. And it looks like I actually have 2. Do you see that right here and here? So -5, and let's just call this negative, like 8.5. So x is -5 and -8.5. Okay, so we'll say x is -5, comma, -8.5. Okay, so we've got 2 examples of evaluating a function using a graph. Now we could also evaluate a function just using an equation. So I'll give you an equation and show you how to answer those questions. So let's say I have f of x, so this is the first type, this will be our second type, equals 2x plus 1. Let's say it asks us find f of 2, and then all we would do is put the 2 over here where the x is. So we go 2 times 2 plus 1, which is 4 plus 1, which is 5. You just plug in the value in the parentheses of the x value into the equation. Okay. Then let's say they ask a backwards one. They say if f of x equals, let's say 3, find x. So in that situation, they actually give us the y value. They give us the answer. So we're going to put this value here for 3 on the left side. So this 3 is going to go here on the whole left side because it's the y value, it's the answer, right? So we're going to say, okay, well, 3 equals 2x plus 1. And then we just have a cute little equation that we solve for x. Minus 1 from both sides, divide both sides by 2, x was 1. Okay? Now the last way you could be asked to evaluate a function is if you're given a table. So let's show how we do that given a table. So that's our third way. Table. I probably should have been giving titles to these other two. So this first example was here. Here was if we're given a graph, right? And the second example here was if we're given an equation. And then our third example here is going to be if we're given a table. So, table. All right, so we're given this table, and it's going to ask us a few questions about it. So, just like this. We have an x, we have a y. I'm just going to put in some random numbers. And then we'll go like this. Like, I'm not trying to make like a pattern or anything. I'm just putting in some random numbers. Okay, so let's go through the two types of questions you'll see. So if it says find f of 2, right? This is going to be the x value where x is 2. So we look at the corresponding y value, and we see that when x is 2, we have a y value of negative 10. So that's our answer for f of 2. Then let's go backwards. So what if it says if f of x equals 5, find x. So this is giving you the y value, right? So here's the y value. So you look under y and you say, oh, there's y is 5. And so x must have been 4. So x is 4, right? So if you look at that for that question, and for the first question, you looked at that negative 10. All right, that is your quick review of Unit 3, all about features of functions and evaluating functions. I would definitely recommend copying this down into your notes and then moving on to the STR. The code for the STR, once you're ready to move on to that, is Unit 3. Capital U, no spaces, with the 3 at the end. All right, good luck.